Hello and welcome to this video on changing between improper fractions and mixed numbers. So what exactly is a mixed number and an improper fraction? Well, a mixed number, as you can see on the left, is a combination of a whole and a part of a whole. So you've got the whole number part of the mixed number and the fraction part of the mixed number. An improper fraction is where the numerator is bigger than the denominator. So, example number 1, you can see a picture here. What exactly have we got here? Well, we have got one whole cake, or one whole circle, and 2/3. So one whole and 2/3. So this is the mixed number that I have written here. And as an improper fraction, I have to have it in terms of thirds. So if you're ever converting between these, you need to remember the fact that the denominators are always going to be the same, because we're talking in terms of thirds. So how many thirds have I got? Well, I've got 1, 2, 3, 4, 5. 5/3. So there is my improper fraction where my numerator is bigger than the denominator. Example 2. Again, I've got one whole circle shaded in blue and a part of a whole circle. So I've got 2/6 of this circle shaded here. And as an improper fraction, so remember the denominator is always going to be the same. It's going to be in terms of sixths. And how many sixths have I got? Well, obviously the 6/6 make a whole, so 1, 2, 3, 4, 5, 6. And then 7, 8. So 8/6. And you can simplify these, but I'm just going to keep them as 8/6 for example purposes. Example number 3. I've got one whole here on the left and 3 what? Let's count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3/10. So one whole and 3/10. And as an improper fraction, my denominator is always going to be the same as the denominator here. How many tenths have I got? Well, 10/10 make one whole. So 10 there, 11, 12, 13. 13/10. Example 4, one whole cake and 2/5. And how many fifths is that? Well, 5/5 make one whole, so that's 5, 6, 7. 7/5. Example 5, I've got 2 whole circles coloured in green now, and 1/4. That's that one over there. And how many quarters is that? So remember, the denominators are always the same. How many quarters? Well, there are 4 quarters in 1, so there are 8 quarters in 2, plus that 1 is 9. 9/4. Example 6, I've got 3 whole circles here now and 1 little third over here. And how many thirds is that? 3/3 makes 1, 6/3 makes 2, 9/3 makes 3, 10/3. So that's your mixed number and your improper fraction. Okay, change 1 4/5 into an improper fraction. So how do you do it when there is no diagram there to help you? So one way that you can think about it, I skipped one over there, going back to example 7. So one way that you can think about it is the fact that we know that in one whole there are, well, how many fifths? Because we're working in terms of fifths, because that's what is on our denominator. So we're working in terms of fifths. How many fifths in one whole? Well, I hope you're saying to me 5. There are 5 fifths in 1. So some people like to think about it as multiplying this number by this, because if we are thinking in terms of fifths and we've got 1 whole cake here, we're going to have 5 fifths, which is 1 times 5. 1 times 5 is 5, 5 fifths. Plus the 4 fifths that you've got here. So 1 times 5 is 5, plus the 4 gives you 9 fifths. 9 fifths. So how did I do that? I multiplied the 1 by the 5 to get 5, and I added on the numerator, the 4. Example 7. So let's apply that same rule again. If we're working in terms of tenths, we know that in 1 cake there's 10 tenths. So in 2 cakes there's going to be 20 tenths. How do we get that quickly? We do 2 times 10, which gives us 20, and then we add on that 7. So 2 times 10 is 20, plus the 7 gives me 27. What are we working in terms of? Remember, the denominator is always the same. We are working in tenths. What about this one? Well, now we have 3 wholes. So if we're working in terms of eighths, we know that 1 cake has 8 eighths, 2 cakes has 16 eighths, and 3 cakes have 24 eighths. How have I got that 24? Well, if you do it quickly, you can get it from 3 times by 8. So 3 multiplied by 8 gives you 24. And then you add on the 7. So 24, add on the 7, I get 31. And what are we talking in terms of? We're talking in terms of eighths. So I did 3 times 8, which is 24, and I added on 7 to get my numerator of 31. This example, 4 times by 9, let's do it quickly now. 4 times by 9 is 36, and then add on that 8 gives me 44. 44 what? Well, we're always talking in terms of the denominator that is shown there. 44 ninths. Okay, what about going the other way round, changing an improper fraction into a mixed number? Well, this I would always recommend you say it to yourself. So this, you could say it as 9 over 2, but I prefer to think about it as 9 halves, okay? Because if a 2 is on the denominator, that indicates halves. So if I've got 9 halves, well, 9 halves is what? Well, let's just bring a picture on here. So if we've got 9 halves, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 halves is 4 whole cakes and a half. And there you have it, your mixed number, which is this one. The other way, quicker way you can think about it is how many 2's in 9? Well, there are 4 2's in 9 with 1 left over. 10 thirds into a mixed number. So as I say, to say it to yourself, 10 thirds. Think about it in terms of a picture. If I want 10 thirds, well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 thirds is 3 whole cakes and 1/3 left over. The other way to think about it, of course, is how many 3s are in 10. Well, 3 3s are 9, and then you've got 1 left over. This one, 15 quarters. How many quarters is that? 15 quarters. How many whole cakes does that make? We could do, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 3 and 3 quarters. How could we do that quickly? You could say how many 4s are in 15? Well, there are 3 4s, which make 12, and then there's obviously 3 left over to make it up to 15. Okay, and finally 58ths. Well, I know that 6 8ths are 48, so 6 is going to make 6 whole cakes. 6 8ths are 48, so I've got 2 left over. 6 and 2 8ths. And you could simplify that to 6 and 1/4, but let's just keep it as this for now so that we're keeping our denominators consistent. So how do I do that? How many 8s in 50? There are 6, lots of 8 in 50, with 2 left over. Okay, have a go at these by yourself. Change all of those in question number 1 into improper fractions, and in question number 2, change the improper fractions into mixed numbers. So, pause the video now, have a go at those, and resume the video to see the answers. And here are the answers. Well done for having a go at those.